Good morning. This is your stats sensei, Mr. Spensei, and we're going to do an exit ticket on the empirical rule. So a machine is set to fill cans with Coca-Cola. Suppose the amount per can forms a normal distribution. That's important. It has to be normal in order to use the empirical with the standard deviation of 0.03. So our standard deviation is 0.03. And a mean of 12.05. So mu equals 12.05 because it's the population mean. Sketch the normal curve with the mean and standard deviation. It illustrates the empirical rule and fill the blanks using the estimates for the empirical rule. All right, so we're going to need to draw the empirical rule out, and we'll use that to answer the questions below. So first off, let's go ahead and start drawing this empirical rule. First off, they did tell us it was normal, and it has to be normal in order to use the empirical rule. Now, this isn't perfect, but it'll work. And remember, the normal curve goes from negative infinity all the way to positive infinity. Now, I'm going to go ahead and start off by listing z-scores. And z-scores are just basically the number of standard deviations there are. Well, technically, there's an infinite number this way and a negative infinite this way, but almost all the data lies within plus or minus 3. So we'll go 1, 2, and 3. Probably should have been further out in the tails, but it's good enough. So this is 1, 2, and 3. And on the other side, we have -1, -2, and -3. And just as a reminder, and this will help us out in our answering our questions, 68% are within plus or minus 1. And then we have plus or minus 2 is 95%. And then we have plus or minus 3, which is 99.7%. So almost everything is within that plus or minus 3. Now, that said, there is a little bit out here and a little bit this way, but because it goes to negative infinity and positive infinity. Well, these are our z-scores, but we probably should list our actual values. And this is 12.05. Now, our standard deviation happens to be the distance between this. So our standard deviation here is 0.03. This is 0.03. This is 0.03. And 0.03. Again, 0.03, 0.03, and 0.03. Well, if I add 0.03 to this, I get 12.08. And if I subtract 12.03, I end up getting 12.02. So 68% lie between here. If I add 0.03 to this, I get 12.11. Because it's 2 standard deviations, and at 3 standard deviations, we're at 12.14. When I subtract, and now I'm 2 standard deviations below, this is 11.99, because 12.02 minus the 0.03. And then I subtract 0.03 again, and I'm 3 standard deviations at 11.96. So it says what percent of the cans are within plus or minus 1 standard deviation. Regardless of the problem, if it's normal, it will always be 68%. So that should have been an easy one using the empirical rule. What are the upper and lower bounds for cans with plus or minus? Technically, this probably should have been swapped. This should have probably said lower and upper because that's the way I'm going to write it. My lower bound for 68% is 12.02. And just for my sake, I'm going to label that lower. And my upper bound is 12.08. And we just write it kind of like an ordered pair. The next thing it says, what percent of the cans are within plus or minus 2 standard deviations? Well, that will always be 95% if we're working with a normal distribution, which we are. And once again, we're going to swap these and make it lower and upper. And our lower happens to be 11.99 right here. And then our upper for that 2 standard deviations is 12.11. When I say 2 standard deviations, they really mean two z-scores. And so it says, what percent of the cans are within plus or minus 3? Once again, by the empirical rule, if we're working with a normal, and only if we're working with a normal, it's 99.7%. And that's the way we labeled it up there. What are the upper and lower bounds for cans within plus or minus 3? Well, once again, we're going to swap this order and we're going to go lower bound 11.96 and upper bound 12.14. I hope this helps you out with the normal curve, and we'll see you on the next one.